The third type of area is boundary area. What is the meaning of boundary area? If we have a rectangular piece of land and this boundary is not a straight line, it's like a zigzag. For example, this is boundary here and this is the boundary here, and between these two lines we have a shape like this. This line, it's not exist. The boundary here, it's like a zigzag line. To calculate the area here, we must divide this area into two shapes. The first shape is area 1, it's a rectangle, and the second shape is area 2. To calculate the area 2 here, we have two methods. The first method is a trapezoidal method. To calculate the area by trapezoidal method, we must divide this line into equal spaces, like this. The distance here is called x, and here x, here x, here x. And we must measure in the side, we must measure this height, it's h1, and here h2, here h3, here h4, and here h5. So first, we divide this area into equal sections. Secondly, we must measure the heights here. The area equal x over 2 multiplying h1 plus the last height. The last height for this example is h5. So here the first height and here the last height, plus 2 multiplying the summation of heights between the first height and the last height. So here 2 multiplying h2 plus h3 plus h4. This is the law of the trapezoidal method. But there are three conditions to calculate the area by this formula. The first condition is this zigzag line must be straight lines. This all zigzag line must be straight line, not curved line like this. It's not curved. No, it's a straight line. So the first condition, the line here in this boundary is a straight line. The second condition is all x is equal. The third condition, the edge must be perpendicular in x. So every edge must be perpendicular in x. If the three conditions exist, you can calculate the area by this formula. This is the trapezoidal method. The second method here is Simpson rule. When we use the Simpson rule, if the boundary here, it's not a straight line, but it's a zigzag line. But the zigzag line here, it's not a straight lines like the method before, but it's a curved line like this. So firstly, we must divide this area into equal distance. For example here, this distance x, 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 and all distance is equal. Secondly, in the side, we must measure the height here in the first point. The height here is h1, here h2, here h3, and here h4. Finally, this is h5. The area of this boundary equal x over 3 multiplying in the first height plus the last height. Here the last height for this example is h5 plus 2 multiplying in summation of the odd height. The odd height here is h1 and h3 and h5. We put h1 and h5 here in equation. So the only height remain is h3. So summation of h odd here, for example, is h3 plus 4 multiplying in summation of even h's. The even h's here is h2 plus h4. So here h2 plus h4. To use this formula, we have 4 conditions. The first condition is this line must be curved line. Must be curved line. The second condition is this distance is equal distance. So x is equal. The third condition is all height must be perpendicular on x. So h must be perpendicular on x. And the fourth condition is the number of division must be even number. So here, this is the first division, the second division, the third division, and here the fourth division. So these divisions must be even number, not odd number. So here the divisions must be even number, not odd number. Okay, for example, if we have here an odd number, not even number. For example, we added here a division. This is the fifth division. So here h6 and this distance is equal x2. We can calculate the area here by Simpson rule. Why? Because the fourth condition didn't apply here. Okay, how to calculate the area here? We will neglect the last division. We will neglect the last division here. And we will apply the Simpson rule by this fourth division. We will apply Simpson here. And we will neglect the last division. And the last division here, we can assume this area is a trapezoid like this. It's not accurate here, but it's the only way. And then this area by Simpson rule, it's for these divisions. And the last division, it will be equal like a trapezoid. So the trapezoid, we have here the two parallel bases, h5 and h6. So h5 plus h6 over 2 multiply in the height between the two bases is equal here x. So the area here, because the number of divisions not even, we neglect the last one and we apply Simpson rule by the even piece, and the last division we can assume it like a trapezoid and we can calculate it. It's not accurate, but it's the only way. There are here a special case in Simpson rule. What is the special case? If we have a 3 divisions. The 3 division, it's not even division, but we have a formula for the 3 division. If we have a piece of land like this and we divide it into 3 divisions, this distance is equal x and this x and this x, 3 equal divisions, and we will measure the heights inside. So this is the h1, h2, h3, and this is the h4. The first height and the last height may be equal 0. It's no problem. So the area for 3 divisions, area equal 3x over 8 multiply in the first height plus the last height plus 3 multiply in summation of the height between the last and the first height, h2 plus h3. This special case, we will use it when we have 3 divisions only. Let's take an example here. If we have a piece of land like this, A, B, C, and we want to calculate the area of this piece of land, the first step, we must divide this area to known figures. For example, here A, B, C, it's a triangle, so we can assume this is area 1. The area on the line BC, it's a zigzag line with equal divisions, so we can assume it's area 2, and we can calculate this area by trapezoidal rule. And here we have 4 divisions, and the height is perpendicular to the x's, and x's is equal, and we have here a curved line, so this area we can calculate it by Simpson rule, so we can assume this is area 3. Here area 2 and area 3, we must add it to area 1, but here this part, it must be subscribed from the summation of area 1 and area 2 and area 3. There are 3 equal divisions and the height is perpendicular to the x's, so this part, area 4, we can calculate it by Simpson rule special cases. So here area total equal area 1 plus area 2 plus area 3 minus area 4. If you have the value of area 1 and area 2 and area 3 and area 4, we can calculate the area total. Okay, let's try calculate the area 1. Here area 1 is a triangle. This triangle, we have the length of the line AB, and we have the length of the line CB, and we have the angle between these two lengths. So we can calculate the area by 0.5 multiplying in LAB multiplying in LBC multiplying in sine theta. 0.5 multiplying LAB is equal 350 meter. LBC is equal to 160 meter. And here sine theta, theta is equal 30 degree. 0.5 multiplying in 350 meter multiplying in 160 multiplying in sine 30, it will be equal 14,000 meter square. This is the area 1. Here area 2, let's try to calculate area 2. Area 2, it's a trapezoidal method. So the trapezoidal law is x over 2 multiplying in the first height h1 plus the last height h last plus 2 multiplying in summation of h between the first and the last. We must calculate the value of x. The total length here is 160 meter and the number of division is 1, 2, 3, 4, 5, 6, 7, 8. We have 8 divisions. So x is equal to 160 meter over 8 and it will be 20 meter. So 20 over 2 multiply in. The first height is 0. The last height here is 1. Plus 2 multiply in the summation of the heights between the first and the last height. We have here this height is not given, for example, is 2 meter. So 2 plus 1.5 plus 2.5 plus 1.5 is 3 plus 0.5 plus 2.5 is also 3. Let's try to calculate it. 20 over 2 multiply in 0 plus 1 plus 2 plus 1.5 plus 2.5 plus 3 it will be equal 250 meter. So area 2 is 250 meter squared. We have here area 3. Area 3 we will calculate it by Simpson rule. Let's try to calculate area 3 here. X over 3 multiply in the first height and the last height and 2 multiply in summation of h odd plus 4 multiply in summation of h even. Okay, x over 3. What is the value of x? The total length here is 350 meter and we have here 1, 2, 3, 4, 5, 6, 7 division. So the value of x here, x equal 350 meter over 7, it will be 50 meter. So 50 over 3 multiply in the first height here, the first height, for example here, the first height here is 0 and the last height here is also 0. So 0 plus 0 plus 2 multiply in the h odd plus 4 multiply in the h even. Where is the h odd and the h even? This is the h1 and h2, h3, h4 and here h5. The h odd is the h3. h3 value is 2.5. So we will put here 2.5. And the h even is h2 and h4. h2 value is 2. h4 value is 1.5. So here we will put here 2 plus 1.5. The area here equal 50 over 3 multiply in the first and the last is 0. So here 2 multiply in 2.5 plus 4 multiply in 2 plus 1.5, it will be equal 316 meter, 0.7 meter square. For area 4, to calculate area 4, the area 4 here Simpson the special case. So area 4, 3 multiply in x over 8. The first division plus the last division plus 3 multiply in the summation of h between the first and the last height is h2 plus h3. Three multiply in x is equal 50 over 8. The first height here is 0 and the last height here is 0, and h2 is equal 1, h3 is equal 1.5. So 0 plus 0 plus 3 multiply in 1 plus 1.5. It will be equal 3 multiply in 50 over 8 multiply in 3, 1 plus 1.5. It will be equal 140 meter. 140 meter, 0.63 meter square. So finally, area total equal area 1 plus area 2 plus area 3 minus area 4 . Area 1 is equal 14,000 meter square plus area 2 is equal 250 meter plus area 3 minus area 4, 140 meter, 0.63. It will be equal this number, 0.07 meter square. So we can calculate the area of any shape by dividing this shape into known figures, and by calculating the area of each figure we can calculate the area total of this shape.